For the past few months now, I've been using a VPS when it comes to deploying my applications. Initially, I achieved this by using Docker Compose, defining my entire application stack inside of a Docker Compose YAML file, similar to what I showed in my previous video on setting up a production-ready VPS. For the most part, this has been working well. However, there have been a couple of things that I found to be a little unintuitive. One of these things is when it comes to redeploying my service stack, which I've been doing by manually SSHing into my VPS and running the Docker Compose up command. Whilst I've managed to make this work, it's not exactly the best developer experience, especially when compared to the experience of using other platforms such as Vercel, Netlify, or Railway.app. Not only is this a bad developer experience, but because of the way that Docker Compose works, it also comes with some undesired side effects. The most major of these is that when you go to redeploy your application stack using the Docker Compose up command, it does so in a way that can cause downtime. This is because when Docker Compose redeploys, it begins by shutting down your already running services before attempting to deploy the upgraded ones. But if there's a problem with your new application code or configuration, then these services won't be able to start back up, which will cause you to have an outage. Additionally, by needing to SSH in and copy over the compose.yaml in order to redeploy, I find this prevents me from being able to ship fast, due to the fact that it's a manual process in order to perform upgrades. Instead, I'd much rather have a solution that allowed me to easily ship remotely through either my local machine or via CI/CD, similar to what those other platforms I mentioned earlier provide. However, rather than throwing in the towel and using one of these, or pivoting to an entirely different solution such as Coolify, I instead decided to do some research and look for some other solutions. And I ended up finding one. One that not only solves my issues with Docker Compose, but also allows me to use the same Docker Compose file I already have set up. That solution is Docker Stack, which has quickly become my favorite way to deploy to a VPS. The way Docker Stack works is that it allows you to deploy your Docker Compose files on a node that has Docker Swarm mode enabled, which is much better suited for production services compared to Docker Compose. This is because it has support for a number of different features that I think are important when it comes to running a production service, such as blue-green deployments, rolling releases, secure secrets, service rollbacks, and even clustering. Not only this, but when combined with Docker Context, I'm able to remotely manage and deploy multiple VPS instances from my own workstation, all in a secure and fast way. For example, let's say I want to make a change to my guestbook web application service stack by adding in a Valkey instance. This service is running on a VPS and is deployed via Docker Stack. In order to do so, all I need to do is open up my Docker Compose YAML file and add in the following lines to add the Valkey service. Then, in order to deploy this, I can run the Docker Stack deploy command, passing in the Docker Compose file that I want to use and the name of my stack, which in this case is called guestbook. Then, once it's finished, I can use the following command to check the running services of this guestbook stack, which I can see now has Valkey up and running. All of this deployed remotely on my VPS from my local machine. In addition to this, I'm also able to manage and monitor my application from my local machine as well, such as being able to view the services logs or add secrets securely. As well as this, I've also managed to set up Docker Stack to work with my CI/CD pipeline using GitHub Actions, meaning whenever I push a code change to the main branch of my repo, it'll automatically deploy my entire stack. So yeah, it's a much bigger improvement compared to using Docker Compose when it comes to working on a VPS. But you may be wondering, how difficult is it to get set up? Well, fortunately, it's actually pretty simple. In fact, I'm going to walk you through the steps of getting it set up on a VPS from scratch, before showing you some of the ways you can use it. To go along with this video, I've created a simple web application using Go that we're going to deploy. This app is a simple visitor guestbook that tracks the number of visits to the web page and presents that information to the user, as well as a motivational quote. The code for this app is available on GitHub, which you can easily pull down yourself. There's a link in the description down below. If we go ahead and open up this code, you can see that there's already a Docker file inside, as well as a docker compose.yaml. If we open up this file, we can see that we've defined two distinct services inside: the web application and a Postgres database. In addition to having the Docker file and Docker Compose already defined, the application also has a GitHub action set up as well. Currently, this performs two different automations, the first of which is running the automated tests, which, if they pass, moves on to the second step, which is building and pushing a new Docker image of the application to the GitHub container registry. The interesting thing to note here is that the Docker image itself is tagged with both latest and the same commit hash that is found at the repo at the time the image is built. This makes it incredibly easy to correlate the Docker image with the code that it was built from. This is going to be important later on when it comes to automated deployments. Now that we know what the application looks like, let's go about getting it deployed. In order to do that, we're going to need a VPS instance to deploy the application on. Fortunately, that's where the sponsor of today's video comes in, Hostinger, who have not only provided me with a VPS instance to use throughout this video, but they also have a Black Friday sale going on until the 15th of December, meaning you can pick up a long-term VPS for an incredibly low price, up to 67% off. In my case, I have the KVM2 instance, which not only boasts 2 vCPUs and a comfy 8 gigs of RAM, but it also includes 100 gigabytes of SSD storage and a huge 8 terabytes a month of bandwidth, which would set you back over $1,000 if you were using something like Vercel. You can pick up a KVM2 instance yourself for only $5.99 a month when you purchase a 24-month term, or if you like to go a little larger, you can put my instance to shame and get yourself a Big Daddy KVM8, which boasts a massive 8 vCPUs and 32 gigs of RAM, all for just $19.99 a month on a 24-month term. Additionally, if you use my coupon code DREAMSOFCODE, you'll also receive an additional discount on any of these instances, which is incredibly good value. If that wasn't enough, however, Hostinger are also throwing in some premium features as well for Black Friday, including free real-time snapshots of your VPS, and free automatic weekly backups, making it incredibly easy for you to recover your instance in case something goes wrong. So to get your own VPS instance, visit hostinger.com/dreamsofcode. And use my coupon code DREAMSOFCODE to get that additional discount. A big thank you to Hostinger for sponsoring this video. With our VPS in hand, let's go about setting it up in order for us to be able to deploy our Docker stack remotely. To begin, you'll want to make sure that you're using the same operating system that I am, Ubuntu 24.04. Then you'll want to go through the additional steps of securing your root user by adding in a strong password and setting up your SSH public key. Next, if you have a spare domain name lying around, then you may want to add a DNS-A record to your VPS. If not, then you can buy a pretty cheap one from Hostinger if you like. Myself, I actually bought the Zenful site domain to use for this video for only a single $1. Either way, once your VPS is set up with your optional A record pointing to it, go ahead and SSH in as your root user. One thing to note is if you're going to use this VPS as a production machine, then I would recommend going through the same steps I mentioned in my previous video on setting up a production-ready VPS, such as adding in a user account, hardening SSH, and enabling a firewall. For this video, I'm going to skip all that, just so we can get into the good stuff. However, if you don't feel like watching another video in addition to this one, then I've created a step-by-step guide on the steps I would normally take, which you can find a link to in the description down below. For this video, however, now that we're logged in, the next thing we want to do is install the Docker engine. This is pretty easy to do so. All we need to do is head on over to the Docker website and copy and paste the following 2 commands into our terminal. The first of these is used to add Docker into the apt sources, and the second one is used to install the Docker engine. You'll notice that in the second command, I'm ignoring both the BuildX and Compose plugins. This is because we're not going to need them. So I'm reducing the amount of bloat installed on my system. Once Docker is installed, we can check that it's working by running the following docker ps command, which shows us that we're good to go. With our VPS set up, let's go ahead and now exit out of SSH, as we're going to deploy our application remotely. In order to do so, we first need to change our Docker host to be that of the VPS, which we can do a couple of different ways. The first and easiest way is to just set the Docker host environment variable, pointing it to the endpoint of our VPS. Whilst this approach works, instead I prefer to use the docker context command, which works in a similar way, but allows you to store and manage multiple different Docker hosts, making it easy to switch between them when you have multiple machines. To create a new Docker context, we can use the following docker context create command, passing in the name we want to give it. Then we can define the Docker endpoint by using the --docker flag. As for the value we want to use here, I'm going to define this as follows, which sets my host to that of an SSH endpoint. Here is how I have my SSH endpoint set up for my own context. You can see we're specifying the SSH protocol with the SSH:// as well as the username of my user, which is root, and the hostname of my VPS. If you don't have a domain name set up, then you can just use the VPS's IP here instead. Now, if I execute this command, my Docker context should be created. The last thing to do is to make use of it by using the docker context use command, passing in the name of the context we just created. Now, whenever we perform a docker command, instead of this taking place on our local machine, it will instead take place on the Docker instance of our VPS, allowing us to configure it remotely. With our context defined, we're now ready to set up our node to use Docker Stack. In order to do so, we first need to enable Docker Swarm mode on our VPS, which we can do using the following Docker Swarm init command. Upon running this command, you should then receive a token that will allow you to connect other VPS instances to this machine in order to form a Docker Swarm cluster. Whilst this is really cool and something we'll take a look at another time, we're not going to do that in this video, so you can safely ignore this token or just save it somewhere else if you want to. But don't worry too much about losing it, as you can easily obtain this token again if you need. With Swarm mode enabled, we can now deploy our application using the docker stack deploy command, passing in the path to our dockercompose.yaml using the -c flag. The last argument to this command is to name the stack, which in my case, I'm going to call zenfulstats. Now, when I go and execute this command, we should see some output letting us know that the stack is being deployed. And once it's completed, if I open up a browser window and head on over to my domain name of zenful.site, I can see that my app is now deployed. Additionally, this remote deployment also works when it comes to private images, like the one that I have here. If I go ahead and change my compose.yaml file to make use of this private image, followed by running the docker stack deploy command, we can see that it's deployed successfully. However, there is the following warning message that we receive, which is only really an issue if you're running a Docker Swarm cluster, which in this case we're not. However, to resolve this, you just need to use the -- with registry auth flag with the docker stack deploy command. With that, the application is now up and running, and we didn't even need to copy anything over onto our VPS. Now, to be fair, you can actually use both Docker context and Docker host to deploy Docker Compose remotely as well. In fact, this is what I did initially once I discovered it. However, when doing so, I kept running into an issue that would cause my deployments to fail whenever I ran Docker Compose up. This was because of how Docker Compose manages secrets, which is that they need to be available on the host system in a file. Whilst this in itself wasn't too difficult to set up, the issue that I had was related to defining the file inside of the compose.yaml. Initially, I used a relative path, which caused problems when running the commands remotely, as it would instead resolve to my local machine's path instead of the local path on the remote. Therefore, I needed to instead use the absolute path to the secret file as it related to my host. But this meant I couldn't use Docker Compose locally. Additionally, there was no easy way to manage the file on the machine without resorting to SSH, and having this secret stored in plain text on the machine felt bad from a security perspective, and not very production ready. All of these issues were actually the main reason I started looking into Docker Stack and Docker Swarm, as they have a much better approach when it comes to managing secrets. The Docker secret command. This command will allow us to create the secret inside of our Docker host, in a way that's both encrypted at rest and encrypted during transit. To show this in action, let's quickly open up the Docker Compose YAML file and scroll down to where our database is defined. Here you can see I've been kinda naughty, as I've set the database password in both the web application and my database service as an environment variable. Shame on me. Let's go ahead and change this to instead use a Docker secret. To do so, let's first create a new secret using the docker secret create command. The first argument of this command is the name of the secret that we want to create, which in my case is going to be db-password. Then we need to specify the actual secret's value itself. As I mentioned before, Docker secret is very secure, so we can't just enter in the value of the secret that we want to create. Instead, we need to either load this in from a file or load this in through the standard input, using just a dash. To add a secret via stdin, you can use something such as the printf command when it comes to macOS or Linux, piping this into the docker secret create command as follows. When I go ahead and execute this command, it will then return the ID of the created secret, which we can also view if we run the docker secret ls command. One thing to note is that this secret is now secret. There's no way for us to retrieve this from Docker. For example, if I run the docker secret inspect command, you can see it gives us a bunch of information about the secrets, but not the actual secret value itself. This is a good thing when it comes to security, but you'll want to make sure that you're securely keeping the secret somewhere else as well. With our secret deployed, we can now use it similar to how we would with Docker Compose. However, rather than setting the secret as a file, instead we define it as external. Then in order to use this secret, it's pretty much the same as if we were using Docker Compose, adding it to the relevant services that need access to it, and then setting it in the associated environment variables. When it comes to the database, this is the Postgres password file environment variable, which needs to be set to /run/secrets/db-password. Then when it comes to my web application, I've created the same environment variable that we can use, which will load the secret from this file. Now, when I go to run this code, we can see that our database redeploys, and our application is up and running. Sort of. Actually, it's not. The database itself is working fine. But if I go ahead and run docker ps, you can see that the new version of the web application is actually failing. This is because I'm accidentally using an old image version that doesn't have the database password file environment variable set up, so it's unable to connect to the database and exiting early. However, you'll notice that if I open up a web browser and head on over to my application, it's still running. This is because Docker Stack has support for rolling releases, which means it's still running the old configuration of my application that works, whilst it tries to spin up a new instance in order to switch over the traffic. It basically acts as a very simple blue-green deployment, but out of the box. This behavior is configured using the following 3 lines, setting the start first value of the deployment upgrade order configuration. Personally, I think this is a great option to enable, as it allows you to have rolling releases when it comes to upgrading your production-ready services, which is especially important if you have automated deployments. Let's go ahead and quickly fix this deployment by changing the image tag to one that supports the db-password file environment variable. Then I'm able to redeploy it using the docker stack deploy command. Now when I go ahead and check this service, we can see that it's running successfully. One thing to note is that whilst this start first configuration is available in the Docker Compose specification, it doesn't actually work when you use it with Docker Compose, or at least it didn't when I tried it. This is because both the Docker Compose specification and Docker Stack specification are shared, which means there are documented configuration options that either one or the other don't support. For example, Docker Stack when it comes to the build configuration, and Docker Compose with the start first update ordering. In fact, another feature that Docker Compose doesn't have support for is built-in load balancing, which both Docker Stack and Docker Swarm do. To show this in action, let me first scale up the web application to 3 replicas, using the docker service scale command. Next, if I go ahead and tail the logs using the following docker service logs command using the -f flag, you can see that the built-in load balancer is distributing these requests against each replica in a round-robin way. Whilst you are able to scale up replicas when it comes to Docker Compose, you're only able to bind a single instance on a given port. This means in order to effectively use load balancing, you need to use an external proxy such as Traefik or Nginx. Now, to be fair, when it comes to my own production services, I actually still make use of Traefik in order to perform load balancing, mainly because it provides the ability for HTTPS and does a better job at forwarding client IPs. This is typically what my Traefik implementation looks like, which sets up load balancing for my web service and automatically generates certs as well. As I just mentioned, there is one issue that I found when using Docker Swarm. Because of the way that Docker Compose handles load balancing, it prevents the original client IP from being forwarded to your services. For some situations, this is pretty annoying, and given by the length of this GitHub issue, a number of other people have also encountered. There is, however, an unofficial solution called Docker Ingress Routing Daemon, which is used in production by a few companies to solve this problem. I want to take a look at how well this solution works in another video, probably when I take a look at clustering with Docker Swarm. In any case, when it comes to my own personal needs, using a load balancer such as Traefik works pretty well. As I mentioned at the start of this video, another production-ready feature that Swarm provides is the ability to roll back a service to a previous deployment. This is useful in the event where a bug is deployed, but isn't severe enough to fail the health check. To show this in action, if I go ahead and change the image of this deployment to be one called broken quote, followed by then deploying it, when I open up a web browser, you can see that the quote feature of my web app is broken, as the name implies. Fortunately, I'm able to roll this back pretty easily by using the Docker service rollback command, passing in the name of the service that I want to roll back. Now, if I open up my web application again, you can see that the quotes are now fixed. That covers the basic overview of how I use Docker Stack with my applications on a VPS. However, there's one last thing that I think is worth showcasing, which is how I use it for automated deployments using GitHub Actions. To do so, let's take a look at the pipeline workflow file found inside of my guestbook web app, where I have automated deployments set up. Here, you can see that I have the two same jobs that we saw before in order to test and build and push a Docker image. In addition to these, I also have another job called deploy, which is where the actual Docker Stack deployment takes place. Let's go ahead and add this exact same job into my XenStats project. Here, you'll notice that I'm defining the build and push step in the needs field, which means it's required to pass in order for this job to run. Then for the actual steps themselves inside of this job, there are two. The first is to check out the code at the current commit, which is pretty standard in GitHub Actions. The second, however, is a third-party action to deploy the Docker Stack. You can find the documentation for this action on the GitHub Actions marketplace, which provides a full list of the inputs that you can set. Let's go ahead and take a look at these values whilst I configure it for the zenful.site. First of all, let's go ahead and change the name of the stack from guestbook to zenful-stats. Next, you'll notice for the file property, this is actually set to docker-stack.yaml. This file name is commonly used to differentiate between a Docker Compose configuration and a Docker Stack configuration. This, to me, seems like a pretty good idea. So I'm going to go ahead and rename my Docker Compose file to be docker-stack.yaml. Underneath the file value, we then have the hostname for our Docker Stack deploy, which I'm going to change to be zenful.site. Underneath this, we have our remaining two values. The first of which is a user named deploy, and the second is an SSH private key, which is set to a GitHub secret. In order for this to work, we need to set both of these up inside of our VPS. So let's take a look at how we can do this securely. First of all, we need to create a new user on our VPS. The reason I prefer to create a new user for deployments is so that I can easily limit the permissions this user has. This is a good security measure to limit the amount of damage if the SSH private key happens to be compromised. We can add a new user to this VPS by using the following add user command, setting the user's name. In my case, I like to use the name of deploy when it comes to my deployment users. Then, with the user created, the next thing to do is to add them to the Docker group using the following user mod command. This will allow them to perform any Docker actions without needing elevated privileges from using sudo. Next, we then need to create an SSH key pair for this user. This is achieved by using the following SSH keygen command. You'll notice that I'm doing this on my local machine rather than using the VPS. Once the key pair has been created, it should generate two files, one being our private key and the second being our public. Let's go ahead and add this public key into our user's authorized keys. To do so, first change into the new user on the VPS using the su command, entering in the user's password. Afterwards, we can then create the .ssh folder inside of their home directory using the following makedir command. Then, in order to add the SSH public key to their authorized keys, copy it to your clipboard and then run the following command to paste it into the file. With that, we should now be able to SSH into this machine as our deploy user, which we can test using the following command. Next, we then want to restrict what commands this user can actually perform via SSH. This is another good security measure, which again will reduce the amount of damage if the SSH key is accidentally compromised. To do so, open up the authorized keys file that we just created, and add in the following text before the actual key itself. This will restrict the user to only being able to perform the Docker Stack deploy command when using SSH with this key. Now we can test that this is the case by attempting to SSH in as our deploy user, which should be rejected. However, when I go to run the Docker Stack deploy command, this one should work. With that, we're now ready to add the private key to our GitHub repository. To do so, navigate over to the Actions Secrets page found inside of the repo's settings. Then, inside of this page, click the big green New Repository Secret button, which will bring us to a form we can create a secret with. Here, you'll want to set the name of this to be the same value as defined in the GitHub action, which in my case is deploy SSH private key. Then for the actual secret value itself, go ahead and paste in the contents of the private key before saving our secret. Now, if I go ahead and commit my code, followed by pushing it up, when I navigate over to my GitHub repo, we should see the deployment start to work with the deploy job, and it completes successfully. With that, our automated deployment is already set up. However, there's one last thing I like to do, which is to specify which image to use when it comes to deployments. If you remember, for each image that we build in this pipeline, we're tagging it with both the latest tag and the git commit hash of the code that this image is built off. So in order to make our deployments more deterministic, we want to make sure to use this same image tag. To achieve this, we can use an environment variable, replacing the reference to our Docker image tag in our compose YAML with the following syntax, which will cause it to be loaded from an environment variable named git commit hash. If I go ahead and set this environment variable to the last image's hash and run the docker stack deploy command, we should see our service deployed with the image hash we specified. In addition to this, we can also specify a default value for this environment variable in the case that it's not set. This is done using the following syntax, which in this case will set the default value of the environment variable to be latest. With that, the last thing to do is to set this environment variable in our deployment pipeline. This is done by setting the env file option in the stack deploy action. Then we can go ahead and create this env file using a step before this one. Here we're creating a file with a git commit hash environment variable set to the current GitHub SHA value. Now, if I commit and push up this code, we should see the pipeline working without issue. And we can test that it's using the correct image by making the following code change to the page title, committing it and pushing it to the GitHub repo. Then once the pipeline completes, if I check out my deployed web application, we can see it's now running the new version with the updated title. With that, we've covered the basics of how I use Docker Stack when it comes to deploying on a VPS, including how I have it set up for automated deployments. Personally, as somebody who has come from mostly working with Kubernetes, I've been impressed with how lightweight yet functional Docker Stack has been. Whilst it's certainly not perfect and does come with its own caveats, so far I've found it to be a really good solution when it comes to running my own applications. One thing I'm still yet to try is setting this up to work as a cluster, but given how easy everything else has been, I don't expect this to be too difficult. However, that's going to be a video for another time. So if you're interested, then please let me know in the comments down below. Otherwise, I want to give a big thank you to Hostinger for sponsoring this video. If you're interested in obtaining your own VPS instance for a super low price, then either visit the link in the description down below or head on over to hostinger.com/dreamsofcode and make sure to use my coupon code dreamsofcode when you check out. Otherwise, I want to give a big thank you for watching, and I'll see you on the next one.